says the table below shows the mean monthly temperature for a town. We are going to use the sine function to model this data. Now, okay, so it looks like a wave, so it looks like it could be modeled by a sine function, because that's what a sine function looks like, doesn't it? It repeats. It's one of those periodic functions because it repeats. Okay, the general sine curve is given by what does that help us know? From last lesson, the amplitude. Yeah, we learnt about that. Now, what's a bit different? We're used to this x minus c. But they've also got this b out here, which is a little bit annoying, basically, just to make it more complicated. Like, for instance, girls, they're saying, what if it was y equals 4 sine, 2x minus 4 plus 7. Okay, so we could rearrange that by taking the 2 out of those brackets, for factorizing 2 out, and what do you get inside? X minus 2 plus 7. So I'm just giving you an example, that's all. So in this example, can you tell me, what is A? 4, it's that number there, 4. What is B? 2, it's that number there. What is C? Yes, minus 2 or 2? 2, because girls, this minus was already there before. Is everyone okay? So, like, you ignore the minus. If it was a plus, though, then you take the minus 2. So, like, you switch the sign. Does that make sense? So C is 2, and what's D? Beautiful, and it's outside the function. So I just wanted to show you an example of what they're talking about. We haven't graphed one this complicated yet, because it's complicated, but we've worked with most of those numbers. We've worked with like a C, A, and a D. So, in this case, what happened? What changed from the first one to the second one? What changed in those equations? You might want to look at your book, because it might be clearer without all my scribbling. Yeah, T. Why did they bring in T? Temperature. Little t. The little t is like X. So it's this one here. T is time in months. For the big T, which is this one up here, capital T is temperature. Variables that are in the context. Is everything okay? So now, we can find B by considering the period of the function, A by considering the amplitude, D by considering the principal axis, and finally C from the x value of the first point on the principal axis. Here, our function is this here. Let's write it out. T equals A sine B outside of T minus C plus D. All right. We're going to try to find A, B, C, and D. I want to know what the period of the function is. So, here's our first point. Can you find where that is repeated? January here? Yeah. Would anyone like to guess, like, what is the actual period, in other words? What's the distance between them? 12 months or 12. How does that help me find B? Because B is the coefficient of little t. Even though it's outside the brackets, it's still going to be the coefficient of little t. So that equals 2 pi over b. So b on 2 pi equals 1 on 12. Beautiful. Cancel, cancel. Can someone help me with b? Pi on 6, you said it, pi on 6, yes. How can I find the principal axis? The maximum y value plus the minimum y value over 2. What is the max y value? 28 in the table. It was easier to read the exact values in the table, isn't it? Does that make sense? Okay, so that's the max y. What's the min y? Is it 15? I think so. I think you're right. It's 28 plus the minimum y was 15 over 2. Tell me if I'm doing something wrong. What is that? That's 43 over 2, which is 21 and a half. Okay, so girls, that is the principal axis. What does a principal axis look like again? What am I even talking about? It's about here. That's the principal axis. I'm terrible. I should be using a ruler, but anyway. It's about there, y equals 21.5. Is everyone okay so far? Yeah. For a normal sine curve, where's the principal axis? 0. Good. Because it rotates along the x-axis, right? So at y equals 0. So that's been shifted up to 21.5. So look at our function. What does that tell us d is? D is that shift up or down, if it's going down. So D represents that shift, and the shift was 21.5, so D is 21.5. Is everyone cool? Amplitude is max y minus min y, did you say? Over 2. So we're going to do 28 minus 15 over 2, which is 13 over 2, which is 6.5. What does that tell me? What letter? A. And girls, can I just ask you, should A be positive or negative? Have a think about the usual sine function. What shape do we usually, like from 0, 0, do we go upwards or downwards? Upwards. Is this one is sort of, well, this one's actually going, oh, no. This one is starting sort of concave down. I don't think you know that yet. Basically, this is starting with an upwards kind of direction. So I would actually consider it to be positive. If it was straight away going downwards like that, I would make it negative. A is? Yeah, just the positive version. Beautiful. To find C, I like to sub in everything I've found so far, then sub in a point and solve it for C. Let's sub in everything we've found so far. You ready? T equals, what was A? Beautiful. Sine, and now we're using this here, girls. We're using that. Sine, what was B? Oh, yep, pi on 6. Beautiful, thank you. And what is, oh, so T we don't know. C we don't know either. Is everyone okay? And what was D? 21.5? All right, so now I'm going to sub in a point that I know my data goes through. And we generally use the one on the principal axis. What's the first point on our principal axis where y is 21.5? October. Can you see that, girls? That's the first time we're on our principal axis. I'll show you in a minute why that makes life easier. Now, so October, so what X value is that, or little t value? The month number, 10. Girls, I'm subbing the point. Little t is 10 for October, and the Y value is 21.5. Is everyone cool? I'm going to sub that in. And that's just a reminder, that's little t and big T. Okay? So 21.5 equals 6.5 sine of pi on 6 times little t, which is 10, minus c, plus 21.5. What can I do first? Yeah, minus 21.5, and look what happens. Oops. That was terrible, but anyway. Cancel, and cancel. That's why we chose the one on the principal axis. So these would cancel. If capital T was any other value, it wouldn't cancel, and I'd still have an annoying constant. So what does my equation become? Yes. Equals? Yes. Beautiful. What would you do now? Oh, whoa, not 6C. What would you do now? Divide by? Because there's little times there, yep. And that's really nice too, because it's 0. Look how nice this is. Cancel, and this is just 0. 0 divided by 6.5 is 0, so we just get 0 equals sine of pi on 6, 10 minus c. All right. Girls, if at any time you would rather have sine on the left, that's fine. You could just flip them. So, thoughts? How do we get rid of sine? Inverse sine. You're performing inverse sine to both sides. Does that make sense, girls? So you could think of it as, now up to you, I'm gonna give you a little extra and say I'm performing inverse sine to both sides Oops. So what happens on this side? They cancel out. That's the whole point. Cancel, cancel. Oops, whoa. I accidentally cancelled a bit too much there. Anyway, the pi on 6 is still there. What happens on this side? What's the inverse sine of 0? In other words, sine of what gives me 0? You can do it on your calculator if you want to, but it's actually 0. Because girls, remember the unit circle. I just want to remind you again because I want to explain how it all works again. At this point of 0, what's the coordinates of that point? 1, 0. And sine is y. So at that point, sine of the angle 0 equals the y value, which is 0. Do you understand that? And that is why the inverse sine of 0 is just that angle 0. Pi on 6 times 10 minus c equals 0. Is everyone okay? Yeah. And now I can divide both sides by pi on 6. What happens then? Cancel, cancel. 10 minus c equals 0. So then c equals 10. It's just the value here. So, what have we learned? What's a shortcut to finding c?
Little t?
Sorry?
Little t?
Yes, but where? What little t?
Max?
Not the max. Look at your table. It's the x value or little t value in this case where we sit on the principal axis, which is kind of what I was saying in that sentence, but I wanted to show you where it comes from, okay? So, shortcut to finding c. Use the, I'm going to say x value of the first point on the principal axis, e.g., x equals 10 when y equals 21.5, therefore c is 10. So I need to sub that c in the equation. So therefore, t equals, we already had 6.5 in there, sine pi on 6, I'm using this here. Oops. T minus 10 plus 21.5. So the idea is, if you were to graph that complicated function, you would hit at least, you would be extremely close to all those points on your graph. And that would model the graph values, okay? And this, very common question in a test, this type of thing. The following table shows the tidal patterns of a beach over a 2-day period. We can assume high tide corresponds to a height of 1 and low tide corresponds to a height of -1. We're doing that because we just don't know the values of the height. And we know our sine curves generally go between 1 and -1. So for a sine curve, 1 is the max and -1 is the min. So we're just kind of allowing them to be the heights. Because I don't think we're trying to find the height, we're more focused on the times. Plotting these times we get, okay, so girls, what's going on here? We've got on day one up here, we've got low tide at 1:18 p.m., high tide at 6:46 a.m. and 7:13 p.m. So we have to model this entire day. So the day technically starts at midnight there. And then what do we know? After 6 a.m., which is around here, we're at low tide, so we're at the minimum. Then at about just after 12 noon at 1:18 p.m., we're at the high tide. Then a bit after 6 p.m., which is 7:13 p.m., we're back at low tide. So that's our first day. They've decided to go up by 6-hour time slots on their x-axis. Then on the second day, which is here, high tide is at 1:31 a.m. So a bit after the first midnight. So 12 p.m. here is actually midnight on day 1. So it sort of starts our next day. So at 1:31 a.m., that's around here. Then so I'm reading that here. Then at 7:30 a.m., around here, we're at low tide. Then at 2:09 p.m., we're around here. Then 7:57, we're around here. We had a low tide. What is the principal axis of this function? Y equals? Yes. Girls, can you see that we are just oscillating around the t-axis in this case? So in other words, I'm using y and I shouldn't be. What should I actually be using? T is down here. That means it's like x. H is up here. That means it's like y. So how about we write down y equals 0, or actually in this case, h equals 0. That is the equation of the horizontal line that we are oscillating around. Okay? Now, given that, what is the value of d? 0. Good. Yay, we found d already. Now, what is the amplitude of this function? You look at your graph. It's just 1. The max and min are just 1 away from the principal axis. So it's just 1. So what's A? From this point here, we're going downwards, aren't we? So you could say A is -1. Do you understand that? Or you can consider this to be the beginning and say A is going upwards, so it's +1. Here's the thing. It'll work either way. It'll affect, if you make it -1, you'll get a different answer for B and C, so that it'll work out. If you use +1, you'll get a different answer for B and C, and that'll work out. So in actual fact, you can use either. What do you think we should use for A? -1 or 1?
Negative.
You want to, okay, I'm going to go with -1. I heard that first, but I want to show you it still works. It still works. We're going to use -1. What is the average period of this function? Hence, find the value of B. Okay, average period. What are they talking about? Okay, so, girls, let's have a think about this. What times do I know? I really just know the times. I really know the times of these max and min values. That's from the table, isn't it? I want to know, so like, when is this here being repeated? Yep, here, right? Now, if you work it out, if this one here, what time, actually, I'll give you a moment. What time does this happen at? 1:18 p.m. Oops. And what time does this one happen at? Take a moment. This is 12 noon, right? That's definitely midday, right? There's like no ambiguity about that. So this one here must be midnight. Does that make sense? It must be. It just has to be. So therefore, this one up here must be in the early morning because it's just after midnight. And what time would that be then? What's the high tide in the early morning on day 2? 1:31 a.m. And that's p.m. All right, so what you got to do now is work out the time between those two times. They've already worked it out to be 12 hours and 13 minutes. But does that make sense that it's 12 hours and 13 minutes? Yeah. Think about that for a second. Yeah. But here's the problem. They're not all the same time. Look at the difference between now this one at 1:31 a.m. and now this one. What time is that one? It's a high tide after 12 noon on day 2. What time is that? 2:09 p.m.? So that's 12 hours and 38 minutes. It repeats. Oh, okay. So I've got another time, different time. And then when they considered all these ones, the minimums, they got all these. So what's the best thing to do? If we've got all these different times, how do we find the period? Average them, which is hinted at in the question. Basically, if we look at the question again, what is the average period of this function? So girls, first, let's find the average time. So what were the times? And how do I make them like numbers? 12 hours and 13 minutes. Actually, what's another way we can put that in a calculator? The bubble button, yes. This button here, the degrees and minutes one. Okay, so girls, you can actually put 12 hours and 13 minutes by treating it like an angle. You press 12 and then press 12 and then this button here. Then 13 and the same button. Okay, that's terrible drawing. But do you know what I mean? That's a way to put in the time, just as it is without converting it to decimals or fractions. Beautiful. And so what do I need to divide that by to get the average? Can you put that all in your calculator? 12.4. How do I find my value of b? Equals 12.4. You can flip if you like. B, I'm running out of room, on 2 pi, equals 1 on 12.4. And b equals 0.5067. Thank you. Question D. It says, find the coordinate of point x shown on the function, hence find the value of c. X is here, and it's pointing at this point there. How would I estimate the coordinates of that point, the x coordinate? What x coordinates do we know that are nearby? Do we know the x coordinate of this point? It's the high tide on day 1, which is 1:18 p.m. Is everyone okay? Do we know the x coordinate at this point? Which one's that? 6:46 a.m. So, using those two, how might we find this coordinate there? Average, exactly. Because c is the x value. Is that okay? The average of 1:18, thank you. The average of 13 hours and 18 minutes plus 6 and 46, thank you. All right, I want the average of those two. 2 minutes, which is 10 hours and 2 minutes, 10.03. So finally, let's write down the function. Okay, capital H equals. Now, can you tell me what my A was? 1. Sine, what was B? 0.506. And then in brackets, I believe it's t minus c. We put -1, let's put -1. And then what's in brackets? What did you put in brackets, girls? 10, oh sorry.
T minus 10.
Yes, t minus c, which is 10.03. What was d?
0.
Good, because we didn't do any shifting up vertically. And that is our function.